Welcome to VirtualX MasterClass, your gateway to mastering physical sciences grade 10. Today, we embark on an exciting journey exploring scalars and vectors, a crucial foundation for understanding motion, forces, and physics as a whole. I'm joined by an experienced physical sciences teacher, and together, we will break down this topic into 9 key areas to make learning engaging, simple, and practical. So let's begin.
Physical sciences is the foundation of innovation. It explains the world around us, from how cars move, how planes fly, and even how forces interact with everyday objects. Understanding concepts like scalars and vectors helps us analyze motion, build structures, and even develop new technology. If you've ever wondered, how do athletes calculate the right speed and direction in sports? How do engineers design bridges to withstand force? Or why do pilots use directional velocity when flying? Then you're already thinking like a scientist, and that's why this subject is so exciting.
At VirtualX MasterClass, we believe in making learning practical, interactive, and easy to follow. With expert guidance, structured lessons, and engaging real-world examples, you'll gain confidence in applying physical sciences in academics, career fields, and beyond. We'll help you develop a strong understanding of scalars and vectors, the ability to solve real-world problems using physics principles, and practical problem-solving skills needed for grade 11, 12, and university studies.
In this lesson, we focus on scalars and vectors, their definitions, applications, and graphical representations. Here's what you'll learn step by step. Topic 1. Introduction to scalars and vectors. Scalars, quantities with magnitude only, e.g. distance, speed, mass. Vectors, quantities with magnitude and direction, e.g. velocity, force, displacement. Topic 2. Definition of scalars. Scalars are described only by their size or magnitude, e.g. 100 kilometers, 60 kilometers per hour, 5 kilograms. Examples in daily life: measuring ingredients, calculating distance traveled, or checking speed limits. Topic 3. Definition of vectors. Vectors require both size and direction, e.g. 30 kilometers per hour north, 10 newtons to the right. Example: if a runner moves 5 kilometers east, this is a displacement vector, not just distance.
Now that we understand what scalars and vectors are, let's compare them to see how they differ. First, let's talk about scalars. These are quantities that have only magnitude, meaning they have size but no specific direction. Some common examples of scalars are speed, like when a car moves at 60 kilometers per hour. Distance, for example, when you walk 5 meters. Mass, such as when an object weighs 10 kilograms. Now let's look at vectors. Unlike scalars, vectors have both magnitude and direction. This means they don't just tell us how much, but also which way. Some everyday examples of vectors include velocity. For instance, a plane flying at 800 kilometers per hour towards the east. Displacement, like when you move 5 meters north from your starting position. Force, such as when you push an object with 20 newtons to the right. In short, scalars give us only the amount, while vectors give us both the amount and the direction.
That's a great way to think about it. Scalars are simple. They tell us how much. But vectors go a step further. They tell us both how much and where.
Exactly. And that's why vectors are so important in physics. Anytime we study motion, forces, or acceleration, we must always consider both the size and direction of a quantity. Topic 5. Representing vectors graphically. Vectors are represented as arrows on a grid. The length of the arrow shows the magnitude, and its direction shows the vector's direction. Example: a force of 20 newtons acting east is drawn as an arrow pointing right. Topic 6. Adding scalars and vectors. Adding scalars is simple. 5 kilometers plus 3 kilometers equals 8 kilometers. Adding vectors requires both magnitude and direction. Example: a person walks 3 meters north, then 4 meters east. To find the total displacement, we use the Pythagorean theorem. Topic 7. Real-life applications of scalars and vectors. Scalars, cooking measurements, timekeeping, temperature. Vectors, navigation, aircraft, ships, sports, kicking a ball in a direction, and engineering, structural forces. Topic 8. Summary of scalars and vectors. Scalars, size, magnitude only, e.g. mass, speed, time. Vectors, magnitude plus direction, e.g. velocity, displacement, force. Vectors require graphical representation, and adding vectors must consider direction. Topic 9. Practice activities. 1. Identify whether these are scalars or vectors. 10 seconds. 15 meters west. 120 kilometers per hour. A force of 25 newtons to the left. 2. Graphically represent vectors. Draw a 50 Newton force acting east. Add 2 displacement vectors, 3 meters north and 4 meters east. That was an insightful session. Understanding scalars and vectors helps us analyze real-world problems, from physics to engineering to sports. If you found this lesson helpful, there's much more waiting for you. Join the Physical Sciences Grade 10 VirtualX MasterClass Complete course and gain in-depth knowledge, expert guidance, and interactive learning tools to master the subject. Sign up now at www.virtualx.tv, powered by Dragon Alexa. We'll see you in the next lesson.